Hi everyone, we're continuing with verifying trig identities. In my previous video, I showed what I thought was a superior solution for verifying this trig identity. I'm going to show you three other solutions I used before I got to my best solution. And as I stumbled along, I learned a lot. And I think students learn a lot as they stumble along and they try different strategies. You're not going to come up with the best strategy right off the bat all the time. So it helps, first of all, to take a step back and think and strategize, because it may be to your benefit to think and strategize. My most clever strategy, internal consistency, which I applied in the last video, led to far fewer steps than what I ended up with for these other solutions over here, among these first three I tried out. So it's often smartest to take a step back and think, what can really work to get me from the left-hand side in this case to my target, the right-hand side here, in the fewest steps, in a way that's easily explainable. All right. Now, for my three inferior solutions, but still, these are very educational, and you'll learn a lot in terms of the various trig and algebraic strategies you can apply. All right. Oh, and by the way, I like putting parentheses now around my arguments, but if your argument is just theta, it's not a problem. Okay. Method one. A student often looks at something like this and goes, oh boy, I see cosecant, cotangent, tangent. Let's break everything down into sine and cosine of theta. And that was my very first strategy, to break everything down to sine and cosine of theta, using the reciprocal and quotient identities. So my method one. I start at the left-hand side. Here I copied the left-hand side, but you could write LHS instead of copying the left-hand side, but you better indicate which side you're starting at. Again, let's apply the reciprocal and quotient identities to break these things down into pennies and nickels, sine of theta and cosine of theta. All right, cosecant of theta by a reciprocal identity becomes 1 over sine of theta. Cotangent of theta by a quotient identity becomes cosine of theta over sine of theta. Tangent of theta by another quotient identity goes to sine of theta over cosine of theta. Sine of theta is already pretty nice, but it might actually help if we put it over 1, since it's clear that we're going to have to manipulate fractions. That may be a helpful thing to keep in mind. Now, it's okay to apply these three identities all at once, simultaneously, because I'm working on different pieces of the expression. I'm not doing two things on the same thing, on the same part of the expression. Otherwise, you should separate your steps. But here, this goes to this, right? Upper left goes to upper left, upper right goes to upper right, lower left goes to lower left. The lower right basically stays the same, or you put it over 1. So in a case like this, you can do this all in one step, even though you're technically applying three identities at once. Again, you want to separate steps if you're doing more than one thing on one part of the problem, the expression. All right. Now, on the top, we have a common denominator, so we can add those fractions, those rational expressions. So we have on top the fraction 1 plus cosine of theta over sine of theta, and on the bottom, we have this sum of fractions. Now, we could try to get a common denominator down here so that this new denominator down here becomes cosine of theta. To accomplish that, I multiply this fraction. That's one reason why I put sine of theta over 1, so I get a fraction here. It may make things clearer. Let's multiply this fraction by 1 by cosine of theta over itself. So I'm basically multiplying that bottom right fraction by 1. And then I eventually get a common denominator in the bottom here. So again, I multiply sine of theta over 1 by cosine of theta over cosine of theta. It's much more nicely typed over here. I get a common denominator down below, add the fractions, and I get this compound fraction, but at least I have one fraction divided by another fraction. When we divide by any non-zero quantity, say a fraction, we multiply by its what? We multiply by its reciprocal. We multiply by its reciprocal. But do separate the steps. So don't do any multiplication just yet. Do it in the next step. When we divide by a non-zero quantity, we're multiplying by its reciprocal. So I'm flipping the top and the bottom here to get this. Now what can I do with this ugly piece in the lower right? We can factor out sine of theta. You could do a snap substitution. You're basically following this template. You're factoring x plus xy basically, where x is sine of theta, y is cosine of theta. Basically, you could factor out an x or a sine of theta. When we do that, we get sine of theta times the quantity 1 plus cosine of theta. And we are allowed to cross-cancel, cross-divide. Because in the end, when we multiply fractions, we multiply across. We can divide the 1 plus cosine of theta up in the upper left by the 1 plus cosine of theta in the bottom right. Their quotient is 1. Again, we're not worried about domain restrictions right now. Because we could do that even if we had eliminated the little dot here and made this a straight fraction with grouping symbols there. Boom, boom. All right, so these go bye-bye. And we are left with cosine of theta over sine squared theta, basically. But actually, I'm going to leave it peeled apart like that. I like these separated. Because what's the target? Okay, it's good to keep the target in mind. What's the target? The target is this. Cotangent of theta, cosecant of theta. That's our target. And this is looking pretty close. What is 1 over sine of theta? It is cosecant of theta. And what is cosine of theta over sine of theta? It is cotangent of theta. Now, is this our target? Not quite. Our target is officially cotangent of theta times cosecant of theta. So let's switch these factors so that we get the right-hand side verbatim. Cotangent of theta, cosecant of theta. We can put parens. All right. So that took some clever algebra along the way. We do have an appropriate solution, though, although you can see it took longer than the internal strategy session I did before. That's strategy. Okay, we'll look at some more strategies and solutions in the next video.